mass of potassium oxide. So I have potassium, oxygen. I have 2 potassium, and 1 potassium's molar mass is 39.1, which gives me 78.2 plus my 1 oxygen of 16. So when I add those together, I get 94.2 grams per mole. This is the molar mass potassium oxide. Molar mass of aluminum hydroxide. So I have an aluminum, oxygen, hydrogen. I have 1 aluminum, and its molar mass is 26.98. I have 3 oxygen, each are 16, and I have 3 hydrogen, and each hydrogen is that. Okay, so I'm going to add all those up. And I get 78.01 grams per mole. We want to find the molar mass of Prozac. Well, I have carbon, hydrogen, fluorine, nitrogen, and oxygen. I have 17 carbon. Each have a weight of 12.01. I have 18 hydrogen. Molar mass of hydrogen 1.01. I have 3 fluorine, and the molar mass of fluorine 19. I have 1 nitrogen, and I have 1 oxygen. And when I total all that up, I should get 309 grams per mole. Number of atoms in 0.5 moles of aluminum. So start with my given 0.5 moles of aluminum. And I know that in 1 mole of anything, there's 6.02 times 10 to the 23 atoms. So I'm just going to multiply across the top, divide by what's on the bottom, and I get, that thing is really going to stop doing that, 3.01 times 10 to the 23 atoms of aluminum. Okay, number of moles of sulfur in 1.8 times 10 to the 24 sulfur atoms. I start with my given, 1.8 times 10 to the 24 sulfur atoms. And I know that in 1 mole, there's 6.02 times 10 to the 23 atoms of anything. So I'm going to multiply across the top, divide by what I have on the bottom, and I get 2.99, which I'm going to round to 2 sig figs, so 3.0 moles sulfur. Number of atoms in 1.25 moles of magnesium. Start with my given, and I know that in 1 mole of anything, there's 6.02 times 10 to the 23 atoms. So I'm going to multiply across the top, divide by what's on the bottom, and I get 7.525 times 10 to 23 atoms of magnesium. Number of moles in this many silicon atoms. So 2.8, 10 to the 24, oops, there should be 0. Atoms. And I know in 1 mole of anything, there's this many atoms. So I'm going to multiply across the top, divide by what's on the bottom, and I get 4.65 moles silicon. Alright, how many moles of aspartame are in 225 grams of aspartame? Well, I'm still going to start with my given. I want to go from grams to moles, so I need to use molar mass. So I need to calculate the molar mass of aspartame real quick. So I've got 14 carbon, and each carbon weighs 12.1 grams. I have 18 hydrogen, molar mass of hydrogen is 1.01. I have 2 nitrogen and 5 oxygen. So when I add all that up, I get 294.34 grams per mole. So over here at my grams on the bottom, so 294.34 grams, 1 mole on top. So that my grams cancel. And I multiply across the top, divide by what's on the bottom, and I get 0.764 moles of aspartame. How many atoms of potassium are present in this many grams? So 78.4 grams of potassium. I need molar mass to get to moles, and then I can go from moles to atoms. So on the periodic table, in 1 mole of potassium, there's 39.1 grams. So my grams cancel, and I know in 1 mole of anything, there's 6.02 times 10 to the 23rd atoms. So I'm going to multiply across the top and divide by what's on the bottom, and I get 1.21 times 10 to the 24th atoms of potassium. What is the mass in gram of this many molecules of glucose? Start with your given, which is this many molecules of glucose. And I know in 1 mole of anything, there's this many molecules or particles or atoms or whatever it is. And if I find the molar mass of glucose, I know in 1 mole there's 180 grams. So I'm going to multiply across the top, and divide by what's on the bottom, and I get 358.8 grams of glucose. How many atoms of oxygen are present in 78.1 grams of oxygen? So I'm going to start with what I'm given. I know by looking on the periodic table, in 1 mole of anything, of oxygen actually, there's 16 grams. And to go from moles to molecules, I have to use Avogadro's number. So my grams cancel, my moles cancel. I'm going to multiply across the top and divide by what's on the bottom. and I get 2.93 times 10 to the 24th atoms of oxygen. All right, calculate the percent mass percent of carbon, nitrogen, oxygen in acetamide. So I have carbon, hydrogen, nitrogen, and oxygen. So I have 2 carbons, so that gives me 24.02. I have 5 hydrogens, 5.05. I have 1 nitrogen, and I have 1 oxygen. Alright, so when I add all those up, I get 59.08 is the molar mass. So I'm going to take each one of these, divide it by 59.08, 24.02 divided by times 100, and I have 40.6% carbon, 5.05 divided by 59.08 times 100, and I have 8.55% hydrogen, 14.01 divided by 59.08 times 100, and I get 23.7% nitrogen, (16 divided by 59.08 times 100. I have 27.1% oxygen. Okay. Calculate the percent composition of each element. So I have copper and I have bromine. I have 1 copper, 63.55, plus I have 2 bromine. 1 bromine is that. So my molecular mass is 223.35. That's a 3 grams per mole. So I'm going to take my copper total and divide it by my molar mass, and I get times 100, and I get 28% copper. And then my total bromine is 159.8, the 2 times 79.9, divided by the total molar mass of my compound times 100, and I get 72% bromine. And that's the end of the practice.